This is an image that was released by the James Webb Space Telescope showing one of the most distant quasars ever discovered. This object, known as TON 618, lies 18 billion light-years away and has an extremely high redshift of 7.19. It's also the brightest quasar known at this distance. This discovery has been made possible by the amazing near-infrared instrument on board the JWST, which can detect the faint signals from some of the most distant stars and galaxies in the observable universe. But what exactly is this strange object? What secrets does it hold, and why are astronomers so excited about it? Let's find out. TON 618 is classified as a quasar, a term that astronomers use to describe the active galactic nucleus at the center of a galaxy. Think of a quasar like a gigantic black hole that resides in the core of a galaxy, much like our supermassive black hole, Sagittarius A star at the heart of the Milky Way. However, unlike Sagittarius A star, which is relatively dormant, quasars are incredibly active, meaning they consume large amounts of surrounding material, releasing enormous amounts of energy in the process. This energy release makes quasars some of the brightest objects in the universe, outshining entire galaxies in terms of luminosity. The engine of a quasar is a supermassive black hole, a region of space-time with gravity so strong that not even light can escape its grasp. Surrounding the black hole is a disk of intensely hot gas and matter, known as an accretion disk. As the black hole draws in surrounding material, it spins and heats up, emitting huge amounts of radiation that extends across the electromagnetic spectrum. Quasars are incredibly powerful, with some emitting more energy than 100 trillion stars combined. They play a significant role in the evolution of galaxies, influencing their structure, growth, and even their surroundings. Quasars are also highly variable, meaning their brightness can change rapidly over timescales of days or even hours. This variability is thought to be caused by the erratic behavior of the accretion disk as it interacts with the black hole. In the case of TON 618, the light we see today originated from the early stages of the universe when the cosmos was just 7% of its current age. This makes TON 618 an invaluable resource for astronomers seeking to understand the formation and evolution of galaxies in the early universe. And now, thanks to the JWST, we have an incredible opportunity to study this distant quasar in greater detail than ever before. One of the first things that stands out about this image is the bright red color of the quasar itself. This is due to the Doppler effect, which causes light waves to be stretched, shifting the light towards the red end of the spectrum. In simple terms, the light from distant galaxies is shifted towards the red end of the spectrum, making them appear redder than galaxies closer to us. This is because as these galaxies move away from us, the light waves are stretched, increasing their wavelength and shifting them towards the red end of the visible spectrum. This phenomenon known as redshift is used by astronomers to determine the distance to galaxies. The further away a galaxy is, the faster it is receding from us, and the greater its redshift. TON 618 has an extremely high redshift of 7.19, which indicates that it is incredibly far away. It also means that the light from the quasar has been stretched by a factor of more than 2 since it left the source 18 billion years ago. The intense brightness of the quasar is another remarkable feature. As mentioned earlier, quasars are some of the brightest objects in the universe, but TON 618 is particularly luminous. This is partly due to its distance. Because it is so far away, the light from the quasar has had billions of years to travel to us. During this journey, the light has been stretched, causing the quasar to appear dimmer than it would if it were closer to Earth. Despite this, the quasar is still incredibly bright, indicating that it must be extremely luminous in its own right. The brightness of quasars is thought to be powered by the accretion disk around the central supermassive black hole. As matter falls into the black hole, it heats up and emits huge amounts of energy, making quasars true cosmic powerhouses. Interestingly, the image also shows several other galaxies in the vicinity of TON 618. These galaxies are much closer to us than the quasar, with the closest one located about 3 billion light-years away. Despite being much closer, these galaxies are faint compared to the bright red quasar. This is because they are much less luminous. Even so, the image provides a valuable glimpse into the crowded universe as seen from Earth. With so many galaxies packed into a small area of the sky, It is hard to believe that there could be any empty space left to explore. Yet the vastness of the cosmos is truly mind-boggling, and there are likely trillions more galaxies out there that we have yet to discover. One of the most intriguing aspects of quasars is their variability. Unlike most other astronomical objects, quasars can change in brightness over periods of days or even hours. This variability is thought to be caused by the chaotic nature of the accretion disk around the supermassive black hole. As matter falls into the black hole, it forms a swirling disk of hot gas that extends for thousands of light years. This disk is incredibly turbulent, with clumps of matter crashing into each other and releasing huge amounts of energy. The variability of quasars has been known for decades, but it was not until recently that astronomers were able to observe it happening in real time. This was achieved by using powerful telescopes such as the Hubble Space Telescope to monitor quasars over extended periods of time. By studying the variability of quasars, astronomers hope to learn more about the chaotic processes occurring around supermassive black holes. This knowledge can then be used to develop a better understanding of how galaxies evolve over time. The study of quasars has led to some fascinating discoveries about the early universe. For example, quasars are thought to have played a significant role in the formation of galaxies. The energy they emit helps to regulate star formation in galaxies and also affects the distribution of gas and dust. Additionally, quasars may have helped to regulate the temperatures of the intergalactic medium, the vast expanse of space between galaxies. By studying quasars, astronomers are able to peer back in time and observe how galaxies formed and evolved during the early days of the universe. This is because light takes time to travel, and the further away an object is, the further back in time we are seeing it. By observing distant quasars, we are essentially looking back in time and witnessing the universe as it was billions of years ago. It is important to note that the exact origin of the energy released by quasars is still not fully understood. While it is generally accepted that the accretion of matter onto a supermassive black hole is the primary source of energy, the mechanisms that convert this energy into the observed radiation are still being investigated. Several models have been proposed to explain the energy release process, but none have been confirmed. This lack of understanding highlights the complexity of these objects and the challenges associated with studying them. Despite the challenges, the scientific community is making significant progress in understanding quasars. With the advent of new telescopes and instruments, astronomers are able to collect data on these objects with greater accuracy and precision. By analyzing this data, researchers are able to refine existing models and develop new ones that can explain the observed properties of quasars. The ultimate goal is to unravel the mysteries surrounding these enigmatic objects and to understand their role in the evolution of galaxies and the universe as a whole. So in conclusion, TON 618 is a bright quasar located 18 billion light-years away. Its light has been stretched due to the expansion of the universe, causing it to appear redder than if it were closer to Earth. Despite being so far away, the quasar is still incredibly bright, indicating its immense luminosity. The image also shows several other galaxies in the vicinity of TON 618, providing a glimpse into the crowded universe. Astronomers are excited to study this distant quasar because it will help them to learn more about the formation and evolution of galaxies in the early universe. By observing quasars, we are able to look back in time and witness the universe as it was billions of years ago. We can study how galaxies formed and evolved during the early days of the universe. As we continue to explore the cosmos, we will undoubtedly make more fascinating discoveries that will expand our understanding of the universe. Who knows what other wonders and mysteries await us in the vast expanse of space? Thank you for watching this video. If you enjoyed it, please like and subscribe for more updates on all my future videos. Have a good night and see you next time.